Hello there and welcome to A2 Maths from June 2018, paper 2, and here we're looking at question 6, an algebraic division type question. So we have f of x equals minus 3x cubed plus 8x squared minus 9x plus 10. Part AI is calculate f of 2, so that's nice and easy to get us started. All we need to do is we need to put x equals 2 into the polynomial, so it's going to be 2 cubed plus 8 lots of 2 squared minus 9 lots of 2 plus 10. Let's work it out all separately. This is 8, so it's going to be minus 24 plus, that's going to be 4 times 8 is 32, minus 18 plus 10, which equals 0. Lovely, I suppose they're setting us up for part 2. Write f of x as a product of two algebraic fractions. So, minus 3x cubed plus 8x squared minus 9x plus 10. Now, by the factor remainder theorem, if we've got a remainder of 0 or f of x equals 0, then that x value is a root. So, one of our brackets can be x minus 2. That's what the first part has told us. Now we need to work out what's going to go inside this second bracket. Now what I need in the first position is something to multiply x by to give me minus 3x cubed. The basic way of thinking about that is I just need to take off a power, so I've got minus 3x squared, times that by another x, I get minus 3x cubed. So let's keep a running total of what we've got when we expand the brackets. So we've got minus 3x cubed. Then if I expand the brackets with the minus 2, I get plus 6x squared. But I don't want plus 6x squared, I want to have plus 8x squared in total, so I'll need to then add on an extra 2x squared. Now, what can I times x by to give me 2x squared? Well, that will be plus 2x. So when I expand the brackets, that will give me my 2x squared. Then it will be minus 4x that will multiply out from the other one. I don't want minus 4x, so I want minus 9x, so I'll have to take away 5 more x's. Now what can I have in the last position to give me minus 5x? Well, I'd need minus 5 to multiply by the x to give me minus 5x. And multiplying out the last two terms, minus 2 times minus 5, that's plus 10, which is exactly what we're looking for. So our answer to A part II is x minus 2, and then in brackets, minus 3x squared plus 2x minus 5. Okay, moving on to part B then. I think we'll need the answer to part A in this part. So it's going to be x minus 2 minus 3x squared plus 2x minus 5. Right, okay then. Prove that, using your answer to part AII, great, we've got that. Prove that there are exactly two real solutions to the equation minus 3y to the power 6 plus 8y to the power 4 minus 9y squared plus 10 equals 0. So, it looks like the only difference between the f of x function and this equation is that the powers have doubled, or in other words, y squared is equal to x. So this function here, the y function, f of y, can be factorised as y squared minus 2, and then y to the minus 3y to the power of 4 plus 2y squared plus 5. Okay, so we know then that inside this bracket here we have y squared equals 2, so therefore y is equal to plus minus root 2. So that's two solutions for y. And there are exactly two real solutions. Well, we need to now disprove that there are going to be any solutions coming out of this polynomial here. So what we'll do then is we'll test b squared minus 4ac on minus 3. We'll do it on the x one, that'll probably be easier. So let's type in b squared first, that's going to be 4 minus 4 times a, which is minus 3, and then times c, which is minus 5. So this is going to be 4 minus 4 times 3 times 5 is 60, so it's going to be 4. Now how many negatives have we got here? 1, 2, 3, so that's a triple negative, so that's 60, so that's going to be minus 56, so therefore no solutions, no real solutions will come out of here, so no real solutions, so therefore there are only 2 roots, only 2 solutions out of that polynomial, and that is y equals plus or minus square root of 2. Okay, moving on to part C now, the tan one. Deduce the number of solutions in between 7 pi to 10 pi to the equation of this thing here. Okay, so it looks like, again, the only difference between this equation and this polynomial is that, well, the signs have all changed, and also that the x's have now turned into tans. So with an equation like this, we can always move things onto the other side. So the equation 3 tan cubed theta minus 8 tan squared theta plus 9 tan theta minus 10 equals 0. If we now just add or subtract everything onto the other side, is equivalent to the equation minus 3 tan cubed plus 8 tan squared minus 9 tan theta plus 10. These two equations are effectively the same thing. Effectively, you're thinking of x minus 2 equals 0 is the same as the equation 2 minus x equals 0. Those two are the same equations, and so is this one here. We just moved everything onto the other side of the equal sign. Okay, so now what we can do is we can use the factorizing that we had before. So it's going to give us tan theta minus 2. And then the next one is going to give us minus 3 tan theta, tan squared theta plus 2 tan theta minus 5 equals 0. Now this part here we've just worked out has no real solutions. So what we're now testing out is the solutions for tan theta equals 2. Okay then, so to do this, let's now draw the tan graph. So remember, it's not going to have any values at 90, so it has its first asymptote at, well, pi by 2. Then it has its next asymptote at 3 pi by 2. So that's going to then be 3 pi by 2 here. So the next intersection is at pi. And if you remember, actually, the easiest way to do this is remember that tan has solutions every pi radians, and if we've got from 7 pi to 10 pi, then there are actually going to be 3 solutions here. If you carry on drawing the graph, you'll see that, but you can just remember the fact that tan has a solution every pi radians, and it repeats itself every pi radians. Okay, so there we are. That's the answer to question 6. 6 marks for that question there. Let's now move on to question 7.